Here is the English translation of your text on the Saga design pattern in microservices. In microservices, to implement transactions across multiple services, there is a design pattern called Saga. The Saga design pattern describes the steps and the way microservices communicate and interact with each other to support a global transaction across different databases. As illustrated in the diagram, we have 3 different services, each with its own database. When a service works with its own database, it has its own transaction. We call this a local transaction. The Saga pattern allows us to coordinate these local transactions, forming a larger transaction that spans multiple services within the same system. Ways to implement Saga. 1. Choreography. In this approach, services communicate with each other directly by publishing and listening to messages. There is no central coordinator. Each service knows how to react to certain events and trigger the next step of the transaction on its own. Example. As illustrated, suppose we want to create an order. We start by creating an order with a pending status. An order in the pending state means it hasn't been fully created yet. When querying the system, we skip orders with a pending status because we know they are in a temporary state, waiting for other microservices to complete their tasks. Once all related processes are successful, the order's status will be updated to created. The order service creates the order with status pending and sends a message to the inventory service. The inventory service receives an integration event from the order service containing the list of ordered products. It checks whether all products are in stock. If stock is sufficient, it sends a message to the payment service to initiate payment. After successful payment, the payment service sends a payment approved message back to the order service. The order service receives the message and updates the order status to created. So here we have 3 microservices that coordinate with each other by sending messages directly. What happens if one step fails? Let's say reserving product succeeds, but payment fails. In this case, the payment service sends a payment rejected message to the order service. The order service updates the order status to rejected. It also sends a message to the inventory service to undo the stock reservation. Alternatively, you could design the Saga so that only the payment service sends the failure message to the order service, and the order service handles undoing any previous steps, such as informing the inventory service to release stock. This means you are the one designing the Saga, and there are multiple ways to coordinate services. Your job is to define a process that is easy to manage and minimizes the chance of errors. 2. Orchestration. In orchestration, a central service acts as the coordinator. Instead of services talking to each other directly, the orchestrator tells each service what to do. For example, the order service sends a message or calls an API on the inventory service and waits for a result. Based on the result, it continues the flow by calling the payment service. The payment service returns a result to the order service, which then decides whether to update the order status to created or, if payment fails, roll back by sending a message to the inventory service to undo the reservation. Besides messaging, orchestration can also be implemented via direct API calls. Some challenges with implementing Saga. 1. Isolation. The I in the ACID properties, atomicity, consistency, isolation, durability, refers to isolation. The idea that changes within a transaction are not visible outside the transaction until it is completed. However, with Saga, isolation is not guaranteed. For example, when you create an order with status pending, other parts of the system can still read it because it already exists in the database. To address this, you should define conventions to prevent other parts of the system from accessing incomplete or in-progress data. Idempotence. Idempotence is crucial in Sagas. A function or operation should yield the same result no matter how many times it is called. When designing a Saga, you should aim to make operations idempotent and order independent, meaning they can be retried or executed in any order without affecting system correctness. In summary, the Saga pattern is essential for handling distributed transactions in microservices. You can implement it using either choreography or orchestration, each with its pros and cons. Proper design decisions regarding isolation, idempotence, and error recovery are critical to building a robust Saga-based system.